All right, let's get going. More people may filter in, maybe not. We'll see how it goes. I want to thank you all for coming. I know it's early on the last day, so I appreciate everyone who's coming here to hear about the DAC and CDB. This is the Using Contained Databases and DACs to Build Applications in Microsoft SQL Server, codenamed Denali, and SQL Azure. Surprisingly, that's actually the short version of the title. My name is Rick Negrin. I'm a program manager on the SQL team. I'll be joined shortly by my esteemed colleague, Adrian Bethune, also a program manager on the SQL Server team. We'll be covering the CDB and the DAC technology and how it can help you solve your business problems. So as we started the most recent round of SQL Server planning, we went and looked at the industry and looked across the landscape at what was happening. And we noticed a couple of things. First was that the amount of applications and the amount of data has just been exploding. Over the last 10 or 15 years, people have gone from tens or hundreds of applications in their portfolio to thousands, even tens of thousands of applications running around the system. Just a huge order of magnitude explosion. And on top of that, the amount of data has exploded as well. We've gone from thinking in terms of megabytes and gigabytes to thinking in terms of terabytes and petabytes. So orders of magnitude increase in the amount of things you have to manage, the amount of stuff you have to deal with. But the tools and the techniques for managing that data hasn't evolved in the same fashion. We've been making incremental progress, making things better, sort of a linear fashion, but not an exponential one. And so we're starting to see a gap between how much stuff you have to manage and the tools and the techniques and the abilities to do it. And the numbers we're hearing is it takes something like 80% of the resources to manage, just to manage the existing apps. And only 20% of the time and energy is spent on building new initiatives, adding new value to organization, driving down costs. And that's a pretty unhappy ratio. Most IT departments that we talk to are pretty not pleased with that ratio. They'd like to see that inverted. They'd like to be able to do 20% managing the existing set of stuff, spend 80% of their time building new things. So in order to make that happen, we need to basically do an order of magnitude jump in the ability to manage at scale. So manage, meaning take care of the resources, the applications, the infrastructure in your systems, and be able to do it at a much higher scale than what we're able to do today. Now, the other thing we noticed is also this funny thing, this cloud computing thing. You may have heard something about it. And so this is not some fad that we think will be here today and be gone tomorrow or fade into the background as like another feature. Definitely at Microsoft, we're all in, which is a little bit amusing and quirky, but actually fairly true. And we do believe this is a fundamental paradigm shift and that the cloud computing is coming and it's going to dramatically affect everything we do and how applications are built and how they're run. But it's not going to happen overnight. There's still going to be, people still have a huge investment in their existing architecture, existing infrastructure. But the cloud computing stuff is coming and it's coming fast. And so I expect that we'll live in a hybrid world for the next several years, at least, where you'll have to manage both things on-prem and things in the cloud. And so being able to manage at scale and manage across these different environments is going to be critical in how we build things. So that leads us to, well then, if we want to go solve those problems, what are the key characteristics that we need to have in the system? And so those things are like scalable and elasticity, scalability and elasticity. I can easily provision new resources without having to spend a lot of time racking and cabling and getting hardware set up, spending a lot of time running setups, installing, putting disks in, and getting things going. That when I need more resources, I can get them just like that. And when I don't need them anymore, they can contract down and be amortized into the system to be used by some other application or some other part of the system. Availability needs to be a first-class mechanism across all the applications in the portfolio, not just the high-end tier one. That availability should be something you get for free by the system, that you should put your app in the environment and it just gets highly available without doing any setup, without doing any work. And last, the self-service aspect is key. It's key to managing things at scale. Today, you might have a good ratio of maybe one admin to maybe 100, say, databases. When you start talking, and when you have 100 databases, that's not too bad. When you start talking 10,000, 100,000, the scale, the number, when those things increase by an order of magnitude, your IT department can't increase by an order of magnitude. And so you need to be able to manage things at a much higher level. And to do that, you need to enable the developers and the app admins, the people managing the apps, to offload as much to them as you can. Have the system automate the mechanism so that they can drive it themselves, their self-service interface, and free up the admins to focus on the higher level aspects of managing the cluster and the environment. So that's sort of some of the key characteristics, and really driving down the total cost of ownership and increasing your agility, your ability to go execute and deliver new value to the organization as quickly and easily as possible. Now, to make those key characteristics possible, we have to build a certain set of mechanisms into the system, into the database. So one of those is about symmetry. So this speaks to the living in a hybrid cloud and on-prem world. That if you're going to live in a world where you're going to have to deploy your applications, and you might deploy them on-prem, you might deploy them in the cloud, you might have to move them around, then you need to guarantee that the application surface area, the APIs that your applications are talking to, is going to be the same, and you're going to get the same behavior and semantics no matter which environment that you go put it in. And so we need to build the capability for you to be guaranteed all the way through the application lifecycle that that surface area is guaranteed, and so that you can go build your application without having to think of application building time. Which environment am I going to deploy to? What does that mean about which APIs I can use? Oh, now I want to switch it. Now I got to switch to a different set of APIs. What you want is one surface area you program to and not have to think about until deployment time where you want to go put it. And so it's sort of a write once, deploy anywhere type model. Second capability is isolation. You need to be isolated from your environment. So the application, today applications commonly sit on top of a piece of hardware, and it's not unlikely that an application will live almost its entire lifetime on that piece of hardware. So those two things tend to be coupled and conjoined together. But in this new world, they're much more likely that apps will have to move. We'll talk about movement in just a sec. But most likely to move to different other systems, move to different environments. And to allow that kind of movement, you need to decouple the application from its underlying infrastructure that it's sitting on. Additionally, there's other kind of dimensions of isolation as well, things like resource governance. If you're working in a shared environment, and that's the kind of environment we have in SQL Azure where you're sharing the resources with other people, you need to be guaranteed that your performance of someone else's app isn't going to affect the performance of your app. So isolation between the applications running in the system. And then thirdly, you need to be guaranteed isolation around security. If you're going to be running your applications alongside someone else's, some other business's applications, they better not be able to see your data. And of course, you better not be able to see their data either. So there's isolation across a couple of different dimensions there. And the third is around deployment, movement, and upgrade. So deployment and upgrade are capabilities you essentially have today, but there are some pain points associated with them. Adrian will be going into more detail what those pain points are and how we're trying to make them better. The movement is, I think, to me, one of the most critical of the capabilities. It's one that people do have to deal with today, but not quite as much as I think they'll have to deal with it in the future. Already internally within SQL Azure, movement is a critical piece of a critical capability that we use to actually implement several of the mechanisms, specifically failover. So when a machine dies for some reason or has a problem for some reason, we can automatically fail over the database to another machine, which means that database better not be tightly tied to the instance or the infrastructure or the hardware. It's got to be loosely coupled so that we can quickly fail over and have it running on another machine. It's how we do rolling upgrades. That same mechanism is how we guarantee that your app stays highly available, even in the presence of us doing upgrades of the underlying system. And for load balancing, we do the same thing. So when one machine gets hot and there's too many databases on it, we move databases off to other machines to amortize the load across the cluster. So those are just three of the reasons we need to use movement internally. On top of that, you may decide you want to move your application from on-prem to the cloud, from the cloud back to on-prem, between data centers in the cloud. So movement becomes a really important piece of technology, a capability that you'll need as you start to try to optimize your system to leverage and get as much utilization as you can. Because utilization is one of the top concerns we often hear from people around leveraging their system. That the typical SQL Server box is in the single digit utilization because they don't have the scalability and elasticity in the way the systems are built today. And so we're moving to a model where we can get much better utilization, but to do that, you need to have capabilities like movement. And last but not least is, of course, the development experience needs to enable all of this stuff as sort of first-class actions all the way from the tooling, all the way through the whole life cycle of developing the application. That all these things shouldn't be things you have to go configure manually after the fact. They should be first-class objects. You declare them intentionally as part of the development environment. And the development environment helps keep you safe from straying outside the bounds of the surface area I talked about, making it easy to do that deployment and upgrade experience. So any questions so far? Is this kind of making sense? So I mentioned that application lifecycle earlier. I just want to talk about kind of what the three phases are, because there's three distinct phases that an application goes through throughout the lifecycle. And the first it shows up as a bunch of source files in a development environment somewhere. Maybe Visual Studio, maybe Eclipse, maybe Notepad, whatever your favorite development environment is. But it starts out there. As you build and get to a certain level of functionality, a certain level of quality, you then sort of snap it, and you move it into what we call the definition phase. So this might be like an MSI for Windows, right? But there's some package that packages up the representation of your binaries or of your schema for a database. And then that package can then be used to go and deploy the application or upgrade the application wherever you need to go put it. And then the third phase is what we call the runtime container. This is where you hydrate your schema into, or deposit your binaries. And then this is where runtime data is then stored as well as the schema. So you deploy a schema and then store the data. And so this is a general sort of definition that we can apply across many of the different application technology types that we have at Microsoft. Now, specifically for this discussion, we're talking about the RDBMS, the SQL Server OLTP model. And that model, the definition is something we call a DAC pack. That's how we package up the schema and the schema objects that you've developed in your development environment into something you can now deploy or upgrade in your system. And then the set of services represented by the arrows, the building, the deploying, upgrading, extracting, and the reverse engineer, is what we call the DAC framework services. And those, that's a set of technologies that take the DAC back and kind of can do all those workflows. And then lastly, of course, you have the container itself. Not surprisingly, it's a database. So there's nothing new there, nothing really magical about what the thing that's holding your data is. But there's a funny word there on the front, the contained database. So we've added that modifier for a reason. And I'll kind of talk about what does contained mean and why is it important to this discussion as we get further into the details. So basically, the rest of this talk is more focused more or less on the definition, the DAC pack, and the CDB. We do touch on some of the development environment, but most of that we've left for some of the other sessions that happened earlier, the codename Juno project, where they talk about the full development environment. But Adrian will touch on some of that as he talks about the DAC pack and the workflows between them. And then I'll be talking about the CDB in just a moment. But before we get into that, I want to kind of talk about where we are today and how we're going to get there, specifically around symmetry. So I mentioned symmetry and how we're going to get to one surface area that runs in all environments that you can easily target from your development application and then deploy anywhere. So we're not quite there today. So today we have the existing database model. We call it the plain old database model. And that the same thing that you know and love from SQL Server 2008. In SQL Azure, we have basically what we call the first incarnation of our contained database. And I'll explain what contained means in a moment, but I'm taking on faith that that's the first incarnation. But to get it to work, we had to turn off some features. So for those of you familiar with SQL Azure, there's certain features that aren't yet supported in SQL Azure. Things like full-text search, CLR, service broker, turning on things like recursive triggers, and minor T-SQL. So we do support most of the core relational stuff, but there's some things that aren't yet supported. And they're not supported because we couldn't figure out how to make them contained in the short term. So we turn them off, and then we'll slowly over time turn them on. And then SQL Azure had DAC support more or less out of the gate in 2010. And then 2008 R2 is around the same time we also released DAC support for the box product. So Denali, which is the next version of SQL coming out shortly, we start to introduce the notion of containment. So we didn't fully get there. That's why there's the partial containment. So we've made some progress, but it's a large chunk of work, and so we've staged it over a couple of releases. And so I'll talk about some of the work that we've done in Denali so far to start making progress to getting the database to be fully contained. But basically about halfway there. And then within Azure, like I said, it's started out fully contained, and we're slowly increasing the surface area, adding more and more features. And so you'll see some of the features that we've done in Denali will show up later this year in SQL Azure. And of course, be increasing the amount of surface area on the DAC and the features for the DAC as well. And then going into, basically by the end of 2012, we'll have put back in sort of most of the features into SQL Azure that are on the box. And then the release after Denali, SQL Server Denali +1, I noticed there's no date or time scale there because we don't have one yet. But sometime after Denali, we'll ship another version, and that's the version that will have the fully contained database. And we'll sort of align with what's in SQL Azure. And then from that point forward, everybody lives happily ever after. We develop features for both in sort of an aligned and a parallel fashion. Things will actually show up first on the cloud and then trickle down to the box as the box does its release. But they'll go more or less in lockstep And we'll have a versioning mechanism that makes it easy for you to target a particular surface area and be guaranteed that it works in all the places. So that's how to think about our symmetry roadmap. I know we're not quite there, but over the next 2 years, we're going to kind of align those two and get to a very happy place. OK, so let's drill into the details and kind of explain what this contained database thing is. So first, let me explain some of the pain points that led us to develop this notion of contained. So when you think about, I want to have a boundary or a package for my application objects, right? The objects that are part of what I think of as my application, right? Versus the things that are part of the system. You might think, oh, the database seems like a reasonable boundary. It stores my tables, it stores my procedures, my functions, my triggers. You know, seems like good enough. Why not just leave? Why just say declare the database is good enough and move on? So it turns out it's not good enough because there are some parts of your application that aren't stored in the database. Things like collation. People often depend on the fact that the collation, they depend on the instance level collation, the SQL Server instance collation, and leverage that in their database. Things like logins. So logins are how you authenticate to a SQL Server. So how many of you understand how logins work? Okay, about half of you. So for the rest of you, the way logins work is there's sort of a 2-level hierarchy of authentication. You create a login, and that login is a username and a password. It's stored in the master database, so outside of the user database for the instance. It's sort of there's one master per instance. And then you create a user object that you store in the database. The user object's bound to a login, and then you grant permissions on that user object for that database. And so when you want to connect to a database, you specify the user you want, or you specify the user you want, and then the password for that login that's bound to that user. And then that's what figures out how to grant you what permissions you need. And there's other things like link server definitions. Then there's some also aspects around collation with regard to TempDB that we'll talk about in just a moment, as well as agent, replication, DB mail. So it's a whole set of things that people consider part of their app that aren't stored in the database. So what do you think happens when you go try to move this database over to another instance? Things break. And for those of you who've ever tried to move a database over, you've probably seen this firsthand, right? So the collation you're using, the queries you're running suddenly start returning values in different order because the collation is different on the other side, and you're depending on the instance collation. Or you try to log into the database and it fails because the login that it needs is not present. And so we really want all these pieces of the application to be contained inside that database boundary. Harden up that database boundary, kind of tweak the system so that all those things can be stored inside, and you can guaranteed when you do that move that everything will keep working. So that's what contained database is about. It's really not about changing anything fundamental about the data model or how things work. It's about taking all these pieces that right now are outside the database and putting them inside so that you can be guaranteed that movement is easy and that we can easily isolate the database from the underlying host. Any questions? All right. So to do this, we basically did an inventory of all of the kind of mechanisms that we had. And this is not an exhaustive list. So if you see your favorite feature is missing, don't worry, it's not going away or anything. This is just an example sort of list of stuff. And we sat down and kind of thought, as you can see, guys in the pictures are thinking very hard. You know, what side what side do we want it on? For a given mechanism, is it part of the application or is it really part of the system? It should be managed by the system. And then as we kind of went through and made choices, we said, all right, resource governance and setting up HA, that should be part of the system. The application developer shouldn't have to think about that. And we kind of moved that over to the left side to the instance and system level. But collations, yeah, that should be a database level thing. Authentication, yeah, that should be a database level thing. And we move those things over to the right. And then basically we draw a hard boundary between them. And that boundary is essentially when you connect directly to a database and you're inside the database scope, you can't touch or mess with the things on the left. And so you can't escape outside of that database boundary. So basically, to configure the things on the left side, you have to connect to the instance or connect to the master or some other database outside your user database. And when you want to manipulate and run your application, you connect directly to the database. And that's the separation that we're enforcing now as part of the contained database model. And of course, the system level stuff, we go manage through the system, and it's more or less taken off your plate. So as I talked about on the roadmap, where we are today is that in SQL Azure, it's fully contained, but not all the features are supported. So for example, collation, you can't yet set the database collation on SQL Azure databases. There's a fixed collation that every database gets, and you can't change it. So it does allow us to make it contained, but it's unfortunately, reduces the amount of control you have over the system. And But we are going to be fixing that. So Denali will have this feature coming out, and sometime later this year we'll enable you to go set the collation on the databases as well. But for now, SQL Azure doesn't have some of those features. Now on the Denali side, we still have those features, but we started building in that containment boundary and hardening it and bringing some of those features in. And the two specific features we've been focusing on, one was collations, and the other was authentication. And so for collations, what we've done is we've split the metadata collation out, and I'll talk about what that means in a sec. It's separated from the data collation, and then fixed up some stuff in TempDB. And on the authentication side, what you've done is we've removed the dependency on the login so that you can connect and authenticate directly against the database. And then there's this partial containment thing that's a little bit funny. It's kind of a funny halfway point where we don't actually block you from going outside. So it's kind of a soft boundary. But we do tell you if you do stray outside the bounds of the API that's supported. And we'll do that statically through a DMV and then dynamically through some X events. OK. So I talked about the splitting out of the metadata collation. So by metadata collation, what I mean by that is all the collation that's used for things like variable names, cursors, go-to labels, table names, temp tables. Today, that actually comes from the instance that you're running in, not from the database that you're in. And so things can get wonky when you move your database around if your variable names are affected by the collation. And I'll show you an example of that in a demo in just a moment. And so we decided, you don't really need to have different collations for your metadata. There's really no reason for that. So we took those things, sort of separated them out, and they have a fixed collation. So once you move to the contained model, you can't ever change the collation to affect your metadata. The metadata is fixed for everybody, and it's this Latin 1 general 100 collation. We've kind of called out that the SC is a little bit off to the side, but it should be next to the KS. I just want to call out that we're using the new surrogate character. This is a new feature in Denali, so small plug for surrogate characters. They implement UTF-16. They make UTF-16 character functions actually work better. So it makes the collation a little bit more correct, essentially. But that's the collation that we have for metadata, and it's fixed, and you can't change it. And then for the actual data, table data, nothing really changes there. That still is bound to the collation of the database. But it's not affected by the instance collation. The database, you have to have a collation of the database, and that's the collation of all of your data. And then temp tables behave a little bit differently, session-based temp tables. In that today, they typically are bound to the instance collation. And so that can cause problems, which I'll show you an example of in a sec. Now, by default, the temp table will pick up the collation of the database that it's created under. So it just makes for a much more natural experience. And on the authentication side, like I said, there's basically a new user type. It looks just the same, and I'll show you a demo of this. But it's not mapped to a login, essentially. And so it basically carries a password hash. You specify a password, and that password is stored in the database, not in the master database like the login is. And then that allows you basically to authenticate directly against that database without having to connect to the instance. So that's for SQL logins. Now, Windows logins have the same behavior, but they were a little bit simpler because you don't store a password anyway. And so we didn't have to create a new user type. But the difference here is you don't need to bind your Windows login, your SQL user to a login for the Windows authentication. So it's a little bit simpler, but same model. Okay. Any questions so far? Making sense? All right. So let me switch and kind of show you some of this in some code. C? Yes. Yeah.
If a Windows ID was granted instance level permissions, like DB creator,
Okay.
if you took that database and then put it on another server, you'd still have that gap, right?
Yeah. So the question is, if a Windows login was granted instance level permissions like DB create, what would happen when you move that over? I'm not sure what happened if you, so when you're in the partially contained mode, I'm pretty sure I'll have to double check this, but I'm pretty sure we won't let you grant that permission for that user because, yeah, that would have to be done with a login. When you're within that contained database, we keep you within the boundary, so we won't let you do things like create databases. You have to go back and connect to the master. But I just want to double check to make sure we don't actually let you grant that permission, because it'd be silly to let us grant the permission knowing that you can't do it. So I'm pretty sure we have that locked down, but I'll double check on that. So what I'm going to basically do is kind of demo some of these problems that I just described, and then I'll switch over and make it they use this partially contained thing. This is a SQL Server Denali bits, so it's, I think, CTP1. And then show you kind of how to fix those problems using the contained model. So the first thing I need to do, so I have two instances here. This one, I don't know if you guys can read that on the back, but this is an instance I created that has the Latin 1 collation as the default collation. And this is a second instance on the same machine that is installed with SQL Denali with the Turkish collation. So first thing I'm going to do is I'm going to create a database. Call it demo. Wait, let me make sure I'm connected to the Latin 1 collation instance. Oh, that's not good. So the demo gods were not kind to me this morning. So I'm going to log into that instance. Okay, so my database was created. Whew. And I'm using my demo database here. Okay, so now what I'm going to do is I'm going to create a table. In fact, I'm going to create two tables. One is table T, just a regular table with a varchar column. One is a temp table, which is the pound U table. That's completed successfully. Fantastic. Now I'm going to demonstrate that I can do a join on two tables. Ta-da. Okay. So that's just setting things up. We're getting to the good stuff. Thank you. Then here we're going to create a function. The function takes in a parameter x, and then multiplies x times a variable that's hard-coded to 1 and returns the value. Now the clever observer will note that the variable is declared as a capital I, and is used later in the function as a lowercase I, which is important. So we'll try that. Creating that works. We'll just make sure that that actually can run. Sure enough, it runs and returns the correct value. And we can create it a table and persist that function in as a column, as a persisted column. And that's all good. Just for completeness, we'll insert some rows, actually select from it, and everything works fine. Okay, so now let's see what happens if I take this database and I detach it and I go move it into that Turkish instance, the instance with the Turkish collation. So can anybody tell me what's going to happen when I go run that query on the temp database? Any guesses from the audience? Yes, that's for the function, but just for I created the temp table and I created the regular table, and I just joined the two. Correct. So the temp table won't exist. That's right. So I'm going to go create the temp table as part of the demo. Once I create the temp table, then I'm going to run the join query. Sorry, I shouldn't be doing this while I'm trying to talk. Hold on one sec. Say that again? Right. So that's exactly right. So I thought I could actually talk and do this at the same time. Turns out I can't. So I'm just going to be quiet for a second while I get this set up. It's unfortunate that they don't have a drag and drop facility. It would make demos very easy. I'll have to ask the Management Studio guys to get on that feature next. All right, so now we have a demo database. It's attached to my instance of the Turkish collation. And then I need to change my connection so that I'm connected to the Turkish instance. Correct. These are normal databases. I haven't done the partial containment thing. You're jumping ahead. Give me a moment. Okay, so now I'm connected to the Turkish instance, so you can see down here. And I'm going to use the demo database, so I'm not running against master. Okay. So now, as gentleman over there brightly pointed out, my temp table doesn't exist because it was a temp table. So I'm going to recreate it. And now I'm going to do my join. uh-oh, doesn't work, right? Because the collation on the original table T, right, that I created when I was under the Latin collation was now collated for Latin. My temp table was now, because I just created it, is collated for Turkish, because that's the instance that I'm running in. And so the same piece of code that I was running that worked fine before on the same database now suddenly fails. Now, this one's not terrible. You can actually work around this one. By when you create the database, make sure you say collate default database, or database default. So that says create your temp table, but go get to the collation from the database I'm running in, not from the instance. And then if you remember to do that, then the select works. So not terrible, but it means every time you create a temp table, you got to remember to put that database default in, and all your developers have to remember to put that in. If anybody forgets, then you're back in the same problem. And then if we go and check our function, as this gentleman pointed out, now I'm getting an error, whereas the code worked fine before. So literally, I haven't changed any code. All I did was move the thing over, and suddenly my function doesn't even compile anymore. Right? And what's happening is, in Turkish, the capital I and little I are actually different characters. So even if it's case insensitive, you'll still get this problem because it's treating the variable names differently. And so it's saying must declare a scalable variable I, because if you remember the function, right? Let's jump up. I declared it as capital I, and then tried to use it as little I. So it's looking for the definition of the little I, which, because it's a different character, it can't find, because it doesn't map it to the capital I. Right. So the question is then, how do you fix that? And that one, there isn't a good workaround. It's remember to make sure you capitalize your characters right in case you accidentally move it to a Turkish collation at some point in the future. And that's pretty tough to remind people to do if they're not used to, if they're used to sort of case insensitivity. So these are kind of problems that show up when you're moving databases around and the kind of stuff we want to help fix. So the fix is we use this notion of a contained database. So I'm going to disconnect. And I'm going to detach this database. I'm going to reattach it back to that Latin collation. The Latin, I keep saying that, the instance with the Latin collation. And I mustn't forget I have to change my connection as well. I'm still connected to the Turkish instance. All right. And then switch to the demo database. Actually, no, I don't want to switch to the demo database. I actually want to do this against master. So I want to alter the database now, and I'm going to set it to be this notion of contained. The containment equals partial, but ignore that for the moment. I'm going to make it contained. What I'm basically doing is causing it to have this new behavior that I talked about, where it fixes these problems I just described. Now I want to use the demo database. And of course, now for completeness, I'll just show you that things still work, of course, in the Latin collation, in the Latin instance, but that worked before, so no surprise there. So I'm going to move this back. So stay with me one more move. So I'm going to take the database, detach it, reattach it to the Turkish instance again. All right, so now I've more or less got the same database. The only difference that was made is that I altered that to the partially contained. Reconnect to Turkish. Use demo. Okay, so now I do that same behavior. So the same thing that I did before when I was in running in the instance with the Turkish collation. I created the temp table, right? And before I did the join, and it failed, and now it succeeds. And what's happening here is because I'm partially contained, or because I'm running in this contained environment, we change the behavior of the temp tables so that they get your collation automatically from the database that it's connected under, rather than from the instance level, and that's why it works, even though I didn't put the database default collation thing on it. And of course, the function, right, had that little I, big I problem before. Now works fine because the function is now using that fixed metadata collation that I talked about. And now you can all clap. Thank you. All right. How are we doing on time? Yes?
If you take an existing database that has SQL ID, make it contain, will it create will it add the ID password at the database level if you then want it to?
So the question was, if you take an existing database and make it contained, will it automatically make the users contained? So the answer to that is no, but that tees up beautifully my next demo, so thank you. If I had a prize, you would earn it. So I'm actually not going to go fully through this demo, but I just want to show you the syntax to give you a flavor for what this looks like. So this is an example of just how to create a regular login. Nothing. This is just a regular login. When you call create login, foo login with password blah, and you do that against master, it puts the login in master. And even if you're connected to a user database, it actually sticks it in master anyway. So I'm not going to run that, but I'm just going to kind of let you take my word for it. And then after that, you go back to the user database that you want to go grant somebody permission to, and you go create a user object there, and then you bind it to the login. So this is all standard login stuff that's all standard today in SQL Server 2008. And so what the new syntax looks like is it's really pretty straightforward. It looks just like that other user statement, only instead of binding it to a login like we did before, you just say with password and specify the password. So that's pretty much it. So if you're switching over an existing database to contained, you do have to go back in and create this user, but it's one line, pretty straightforward. Do it once, and then you're good to go. So I'm actually going to stop there. See if there's any more questions on the content.
On the, who has access then to create logins? Do you now have access to create any login within the database?
No, so you don't create logins in the database anymore. You only create logins are created in the master database. So sysadmins who have instance level permissions can still go create logins there if they want to. Oh, who has permissions to call create user?
Right.
Yeah, the database owner would. And I think there's a permission for it as well that you can grant to someone else if you wanted to grant them permission.
Can you take it away from DBO? I don't want people creating new logins or new users in the database.
That's a good question. I don't know the answer to that. But if you follow up with me offline, I can find someone who will know. I can find out what the answer to that is. I don't know if you can take away the permission to create a user. I suppose you could, but I need to double check.
In your example you just had where you went in and created the login, if you went in and did a subsequent load of the database, do you have to run SP change user login again, or does it actually sync up automatically with that login now that it exists?
Sorry, I didn't catch that. Can you ask that again?
Well, go back to your previous one where you had to go back and make the login.
Yeah?
Okay, if I now reload that database, do I have to do SP change user login, or does it automatically sync up with the existing user that you just made?
You don't have to. You don't have to run anything. You can log in. I can go back and now log in with that user I just created.
Okay, and it will be synced up with the reloaded database because the user.
When you create the user, you do it in the context of the database.
Okay, cool.
You connect to the database and create the user on the database, so it doesn't have to sync up with anything.
Okay, so you're always connecting with the user in the database for that.
Yeah. Yeah. So let me just hold your questions for a bit because I want to make sure Adrian gets his full 30 minutes or I get in trouble with him. And we'll take more questions at the end. So we can write them down or just kind of remember them. Thank you.
What's that? All right. So again, hi, I'm Adrian Bethune, and I'm Program Manager of SQL Server. And I'm here to talk to you about the DAC framework and how that's going to work in conjunction with the contained databases. So as Rick mentioned, there's this application lifecycle that we're trying to build. And this definition in the center is the centerpiece that DAC enables. This definition contains a serialized schema definition for your database application. And it acts as a virtual layer on top of the database. So what that means is that for someone that goes in and authors by building, authors source code and then builds it to produce one, or extracts it from a running database, that DAC pack is symmetrical with a contained database. So it has the same surface area, and it has the same characteristics, same properties, the same schema that you can define, etc. And the DAC framework, it sounds fancy, but to put it into real terms, right now it's a set of client-side DLLs that provide public methods that allow you to do all of these lifecycle services for your actual for your source code, for your definition, and for your runtime container. So some of the problems that we're trying to solve with DAC include schema and data portability. As Rick mentioned, one of the key areas that a lot of folks are complaining about is how do I get enough time to manage all of my databases, do all of the development, et cetera, and still have time to go through and do some innovation. And one of the key things that's going to enable that is being able to port your data and schema between all the different runtimes that are going to be available, including SQL Azure and different versions of SQL Server itself. Kind of one of the artifacts of some of these difficulties are these large script libraries that people end up authoring and maintaining, and they're quite burdensome because most of the development that happens is imperative against SQL Server. You end up only authoring alter scripts against a database in a set state. You don't author a schema. You basically just alter schema in place or add. Another issue is how do you actually version your deployments for your schema or these changes that you're making? Because SQL is just stateful. All these alter scripts that go in, it's difficult to determine exactly what state your database schema is at any point in time. And again, management at scale. So reducing the amount of time that you spend authoring, deploying, and upgrading, these are the key scenarios that we're looking to address with DAC. And so in terms of the containment model that Rick just mentioned, we want to ensure that this virtualized, this logical layer that sits out on top of the contained runtime container is symmetrical with it, as I mentioned previously. And if you remember that back to that lifecycle diagram, the way that we enforce that is every single arrow that's going towards that center definition validates the containment every time. So every time you do a build, we ensure that you don't have external database references and a lot of the other things that Rick mentioned that contained databases won't allow. Same thing with extract. Anytime you're coming into that definition, we validate. Then the model, because it's contained, will provide some guarantees around the schema and data portability. So you can take this definition and apply it to a variety of different server environments without having to worry about what its behavior is going to look like. So to kind of start out and show you some of the new services that we're providing around schema portability, I'm going to switch to my demo machine. And it's coming awake. Just need a second. Okay. Okay. So we'll start in Management Studio. And I'm going to find my mouse. Sorry, it's going to be a little awkward because I couldn't get the resolution set right, so I have to use the larger screen. Please bear with me. So I'll connect to local instance of Denali Bits. That's up and running. I have a particular database, and this database I'd like to start managing using this new containment model and be able to show you how some of the portability services provide an easy migration path to a variety of server instances. So to start with, I'm going to go in and select tasks and register as a data tier application. Now this action, what it actually does is it actually runs through our DAC validation model, and it validates that all your schema and everything inside the database is contained. So I'll click through. Now it's going through and sucking in the schema and hydrating an in-memory model and validating all of the particular objects. Give it a second to complete. Sorry? That's right. The way I got to it is inside of the Object Explorer, right-clicking, selecting tasks, and then registers data tier application. Great. So now I get a nice little summary here. It tells me there are a variety of objects that are supported by DAC and are therefore contained, but there's a couple that are not. And the reason that they're not contained and they're not supported by DAC is because they actually are server level or instance level objects. So before I can proceed, I'm going to actually need to remove these objects from the database. I know that sounds really simple, in this little demo, and it's very difficult to actually do that in the real world. But the incentive is that you get, the analogy I would provide is it's like virtualization, right? As soon as you actually fall into that model, you get some of these other management guarantees and these other services that will save you a lot of time and energy. So I'm going to cancel out of this, crack open the database, and go through my simple removal of the two objects. So there was a proc and some user CLR. Great. So I've removed those. Now I'll go back and now re-register. And this time, I don't get any validation errors. Proceed, and it will successfully register. So at this point in time, what I get is inside this management node, inside this management/data tier applications node, I get a new registration for this particular data tier application. And what's happened here is that the DAC framework has taken a snapshot of your schema and stored it inside of that server instance. So that server instance now tracks the version of the schema and its actual definition for future reference. And I'll get into a little bit of what that actually means a little bit later. Now, new in Denali, and we actually have a public CTP available of these particular services right now, we have these import and export services, which take your schema and your data and put it into a logical format. Then once you have that logical format, you can import it into a variety of database targets, including Azure, Denali, 2008 R2, 2008, 2005. So I'm going to go through a quick demo of what that looks like. And I'm cheating here. I just have the commands are preset. And so DAC's actually connecting now, and it's extracting the schema definition. Once it's finished extracting the schema definition, it'll actually go through and stream out all the data and package it inside of a single file artifact. Now it's finished. Great. So now I have a file artifact locally on this machine. And what I'm going to do is import it into SQL Azure. Again, with a very simple command. This command line tool is actually available as an example on CodePlex, and I can provide a link to that a little bit later. And while it's doing this, I'd like to actually show you what the file artifact looks like. Here's the artifact. Because it's in use right now, I'm just going to make a copy of it. And this artifact is actually an open format. So I can rename it to a .zip, crack it open. And in the first level, we have the schema definition. So we have the physical and logical objects that are defined for your database schema. And then we have the data folder as well, which with actual file for each table that's part of this particular database. And then we have a JSON encoded file, which contains all of your data in a logical and open readable format. And it's just about finished. That's right. Right now, it's everything. So the question was, what are we actually putting into this file? And if you had a multi-terabyte database, would it actually stream all of it into the file? Yes, it would. It would chunk it into 2 gigabyte file sizes for each table that you have. Obviously, it would take a little bit longer. Our performance numbers are actually quite good, given that this is a logical format. We're looking at about 2 to 3 times the time it takes to do a full backup. And we're also seeing about 5 times smaller file size than a full backup. I'll get into that. Right, I'll have a follow-up demo to show you how that works out. This particular, what I'm showing here is just straight database portability. I'll get into the upgrade and the schema scenarios in a little bit. Question?
Didn't you mention that you would actually be able to take a database from a 2008 instance into a 2005 instance?
Yep.
What about features that don't exist in 2005?
So the DAC model right now, it's almost like a lowest common denominator of very, very core features that we guarantee are contained. So right now, the set of features that DAC supports are supported in the various targets that we push to. In the future, as soon as we add more features to the DAC framework as the contained database model grows, we'll also add support for deploy time target validation. So we'll actually validate the model and the features, et cetera, that you have. But right now, it's not necessary because of the strict set that we support. Other question? The question was is there a T-SQL interface for doing all this registration stuff that we're showing? Unfortunately, not at this time. The interfaces that we provide right now, because this is a client-side framework, we have a set of DLLs that have these front-loaded. We also have commandlets through PowerShell that allow you to just script out and run all of these commands through that interface. All right. So returning back to the deck. So then to talk a little bit about that left-hand side of the application lifecycle, we have in 2008 R2 we shipped a version of the DAC, and that version was also included in Visual Studio 2010. So if you have Visual Studio 2010 today, you can actually get started on developing DACs and defining your schema, building and deploying to a variety of targets. And we'll be updating the DAC as well as the tool sets with the Juno release. There have been a couple other sessions on that. I'm not going to cover a lot of what they're doing, but they do support the DAC package builds, as you've seen in the keynote demo for the DBI track and probably a couple of the other sessions. A big advantage that we have in this new model that we're allowing you to define this new surface area that you can define your schema in is declarative authoring. And what that means for developers, you don't have to worry about the ordering in which you're authoring your T-SQL. You don't have to worry about dependencies. You just go in and you author your create statements, and you let DAC and the deployment engine handle all of the dependency checking and ordering and scripting, et cetera. You get a nice IntelliSense experience. You get some designers to help you go through, and instead of having to go through and look at some lexicons for T-SQL syntax. And you get some deep validation. It's one of the key features that we're adding in Denali for DAC is we've worked with the SQL Engine team to actually provide offline validation, deep validation with the actual SQL Server DLL for all the T-SQL that you've authored as a part of your definition for your schema. And lastly, you can provide your own versioning. These DAC pack definitions, they contain a version number. I can show you where that's going to be here in a little bit. And when you hand things off at that point and actually deploy them to a target server, we maintain that version number, and you can always check and see what that version number is. So you can at least get a good sense of what state the schema is in, what was the last deployed schema definition, and see what the changes are that have happened since. So again, I'll jump back and show you a quick demo of what that looks like. So here I have the project Juno, and I'm going to connect to that same instance. And I'll find my database. And again, this is the on-premise or local instance of Denali. And I'm going to create a new project from that database. So select a name, and I'll name it the same. And at this point, it's again going out and selecting out all the schema definition and hydrating the project inside the IDE. A little slow because I'm running, a full instance of SQL and Visual Studio on a VM on a laptop. All right, so now I've got my schema definition here inside of my project. And one of the things I'd like to do is go into my products table. And I have this products ID. And let's say, for example, that I wanted to actually modify the data type for this key column. Could change it. Again, you get the dual view between the designer view and your T-SQL, so you change it in one, you get it in the other. And if I change that key column and try to do a build, I get a validation error. And this is part of that deep validation you get inside of the project experience. What it's telling me is that there is a foreign key reference to this particular key column. So I have to go resolve that before I can actually build a validated DAC pack. So I'll go to the referencing table. Save the change. And before I do my final build, I'll show you the properties where I'll set the data tier application output. And the properties, I can set the version number to be 2.0. Provide a definition here. All right. Save the properties. Finally do a build. All right. Now the actual build location contains a DAC pack now. And I'll stop the demo here and go back, and we'll continue and pick it up in a minute. Now, in terms of the development properties, that's the experience that we're providing in terms of Juno and in 2008 R2 and Visual Studio 2010, this declarative authoring experience that allows you to produce a DAC pack, which you can then deploy separately from the development environment. Now, the services that allow you to do that are the deployment and upgrade services. Deployment just creates a new database. But upgrade actually goes in, takes a look at the schema that exists in the database that you're deploying to, that you're upgrading, hydrates a model in memory, and compares it to the model that you're trying to deploy, calculates the differences, and then deploys just the differences to that target database. And new in Visual Studio 2010 SP1, 2008 R2 SP1, and in Denali, we have the in-place upgrade engine, which we've changed since the first release of DAC, which allows you to do all of these updates in place instead of the original side-by-side engine. So to give you to show you what that looks like, I'll pop back. Remember, I compiled this singular DAC pack from my development environment. I'm going to return to Management Studio. And if you recall, I still have that same database here. I'm going to right-click in the management node on it and select upgrade my data tier application. I'm going to paste in that location. There's the DAC pack I produced as part of my build. Notice that it's version 2.0. At this point, DAC is actually going in and validating that there haven't been any changes to the database since the last DAC deployment, which at this point happened when I did that registration. It stamped the schema definition at that point in time. And because I haven't changed the database, it tells me that there haven't been any changes. And I have a high level of confidence now that my upgrade, that I know the state of my database prior to my upgrade. I have a couple options I'll skip through in the interest of time. And then what DAC is doing here, as I mentioned earlier, is going through and calculating these differences and then providing me with an upgrade plan to show me exactly what the steps are going to be taken as a part of this upgrade. And again, it's a little slow because it's all packed onto a single VM. Great. So I see here a set of actions that are going to be taken for this particular upgrade on this database. And for folks that are kind of concerned of what these changes actually are, these are pretty high-level descriptions. Like if you want to see the actual T-SQL that will be executed against the database, you can save the script down here below and actually take a look at the T-SQL that gets generated. You can apply it yourself or come back to the wizard and go through the rest of the upgrade. And because I'm altering the data type for that column, I get a warning about potentially causing some problems for my data. So at this point, I've proceeded with the upgrade, and I'm going to let DAC go through and upgrade the target database. While it's upgrading, I'm also going to connect to my Azure instance. So now I'm connected to my Azure instance. Come back here and I notice that the upgrade's finished successfully. Now going to my Azure instance, I'd like to actually upgrade this same instance with the same DAC pack that I just compiled. So again, I'll select Upgrade Data Tier Application. Select Next. I will need to grab the location. Give me 1 second. So that's that same DAC pack 2.0, changing from big int to int. Again, it's validating the contents. And again, detecting the change. Make sure that we understand what the state of the database is before we proceed. Hasn't changed. We'll proceed and take a look at the upgrade plan for Azure. Remember, this is that same schema definition that we had that I upgraded the on-prem instance. I noticed that the upgrade plan here is actually a little bit different on Azure than it was for the on-premise instance. And the reason why is because SQL Azure requires the use of a clustered index on any table that contains data. And so what we actually have to do here is do data motion between tables in order to alter that column. And notice I didn't have to change anything about my schema definition. DAC just handles the change in the upgrade plan for me. So again, I'll proceed despite the possible data loss. And I'll let the upgrade proceed. And while it's doing that, now I'm finished. And just to show, sorry, I think I fat-fingered that one. And now I'll try it. I see that my data is all there in my SQL Azure instance, and the column is in fact an integer. So that just gives you just a brief example of the data portability guarantees that DAC provides through the import and export services. It gives you a brief example of how authoring in the declarative format allows you to get a little bit of a leg up on not having to worry about the alter scripts that you typically generate and the scripts that you have to maintain, and the upgrade services that we provide in place that allow that account for the differences between the various engines that DAC supports. So we'll return back to the deck. On the local server?
Do you also support the upgrade of the table itself if it's being replicated to other subscribers?
Yes, because the upgrade's done in place, we don't affect any of the replication that happens behind the scenes.
So it automatically would replicate the table structure change to the subscriber.
So again, the question was if there's replication enabled on the local instance to a separate subscriber, would the in-place upgrade affect or be published to anything else? And the answer is yes, because all we're doing, DAC acts as a client-side binary, so we don't do anything special server-side. We connect as a client, and we execute T-SQL. So if you have replication enabled, depending on the replication settings that are set, because some of them actually do affect a user database and are not supported. But we do just author the T-SQL statements. There's nothing special that we're doing there that would affect any of the settings that you've set for that. Sure. Yes, that's correct. Someone mentioned that if you have replication enabled and you try to modify the primary key, it would fail. And in this case, DAC actually prevents you from upgrading when replication is enabled, depending on the replication settings. So when replication, so SQL Azure actually has a set of replication that's already available. And as you saw, when I did the upgrade against SQL Azure, It did not disrupt or affect the replication settings for that particular database. So in that context, replication does not affect the user database. It's one of those system properties that Rick was mentioning before, one of those system management things that should not affect your user model at all. In those cases, replication is not disrupted by a DAC upgrade. Other questions? Okay. So to kind of wrap up and provide a summary, for symmetry in SQL Azure and SQL Server Denali, we're moving the ball forward. We're providing you with some new properties that allow for strong containment, particularly in Azure. We have to have strong containment because it is a multi-tenant system. And then in Denali, we're providing you with the first steps in the on-premise or local database properties for partial containment. And then in the future, if you remember that roadmap, as we converge the two app models from SQL Azure, which is fully contained, and then provide containment in the on-premise story, then we'll have a full symmetry between the two properties, which provide you with a lot of the capabilities that we were discussing earlier. And then for isolation, we already have full isolation in Azure. We have full containment, again, and then we'll have we already have the partial containment set in Denali, as Rick has demoed. And then in the future, we'll have full containment in both. And it'll be the same containment surface area. Again, that symmetry that I mentioned previously. The movement, deployment, and upgrade, right now, DAC is tied to the contained model that Azure provides. As the contained features become symmetrical in both Azure and on-premise, we will have all of those features light up in DAC. And then lastly, for the development experience, Juno will be the premier development experience for all of these contained application models moving forward. So just open up the floor again to questions and provide the roadmap. And yeah, Rick, please come back up. Sure. So I couldn't quite hear you, but let me try and repeat the question and you tell me if it's correct. Will Team Foundation services be able to pick up on the DAC? Right. Yes, DAC is included with the Team Foundation server and services that are going out with Visual Studio 2010. Question?
How does that align with database projects that we're doing today?
Sorry, this machine's really loud.
Database projects, was that the whole DAC? How does that fit in with database projects?
Yeah, so there's a DAC database project today in Visual Studio 2010. If you install Project Juno on top of Visual Studio 2010, it will actually supplant that project and provide a conversion and upgrade path to the new Juno database project type. And for anybody else that has questions, could we please try and use the mics?
I think we're just about out of time anyway. But I'll be in the booth. I think you'll be in the booth as well.
Yeah, feel free to stop by the SQL booth. Okay.
It's fine.
So apparently we have more time than we expected.
It's fine. If nobody has questions, we can stop here. If anybody wants to come up afterwards, we can kind of chat.
Sure.
But thank you very much. I hope you enjoy.